All right, 24 and 25, determine whether or not the sequence is geometric. If it is, find the common ratio. Now remember, arithmetic sequences have a common difference, so we subtracted or added something between the terms. Geometric sequences have a common ratio. That means we multiply or divide. So in this case here, we're looking, what do we do to 54 to get negative 18? We divide by negative 3. And if I divide by negative 3, I get the next term. And if I divide by negative 3, I get the next term. So this would be geometric with a common ratio of negative 3. Now, or negative 1/3. So again, how would I really want to see the work done? What I want to see is take negative 18 and divide it by the term before that. That's what we call a ratio. Simplify, we get negative 1/3. 6 divided by the term before it is negative 1/3. Negative 2 divided by 6 gives me negative 1/3. So it is geometric. And the common ratio is negative 1/3. Now you do need to be careful with arithmetic and with geometric, okay? You can't just say the common ratio is divided by negative 3. Okay? You have to say the common ratio is negative 1/3. Do they accomplish the same thing? Sure, but the common ratio is a number, and saying divided by negative 3 is not a number. So if you want to do it this way, that's fine. Just remember to adjust it as necessary. I would say, though, it's still better off to write a term divided by the prior term and simplify. So over here, that's a little tricky because how do you do negative 2/3 over 1/3? Well, top times the reciprocal of the bottom. Simplifies and we get negative 2. So I'm going to skip this first step. I'm just going to take 4/3 and divide it by the term before by multiplying by its reciprocal. And I wholeheartedly support canceling and simplifying diagonally when multiplying fractions. So those 3's cancel, as well as a factor of 2 from here and a factor of 2 from here. You don't have to do it that way. You can multiply and reduce afterwards. Either way, though, I get negative 2. And it looks like it is going to be geometric. Okay. Maybe you could look at this next one and see if we're going to get the same thing. Okay. Or maybe you need to do it out. Negative 8/3 times 3/4. And sure enough, the 3's cancel. And we get negative 2. All right, 26, we are given the first term, so that's 4. And all I have to do is multiply that by this common ratio. So I'm going to multiply that by negative 1/4 to get the next term. So let's see, positive times negative is negative. 4 times 1/4 is 1. Multiply that by negative 1/4. Negative times negative is positive. 1 times 1/4 is 1/4. Multiply that.
The second high school break for the students taking MCAT is taking place now. Please report to the cafeteria.
So again, just make sure your terms are alternating. And if you look, your numerators just get multiplied by 1, denominators get multiplied by 4. '27, our first term is 2, that's great, but then it's a little tough to figure out what goes in between. Our third term is 12, we know that. So I just need to figure out the others. Now, some of you might be able to do this if the terms are close enough. You might be able to figure out what can I multiply 2 by to get a term, and then multiply that by the same thing to get 12. So you might be able to figure out what that common ratio is. But again, that's great here because the terms are so close. But if that was the first and the seventh term, it's going to be a lot more difficult. So let's walk through the process. This is where we do something similar to what we did with the linear, where I imagine plugging in 1 and 2 into the general form of the equation. So remember that form is that AN equals A1 times R to the n minus 1. This is that formula you need for geometric sequences. So if I plug in 1 here, A1, that's A1 is the first term, so that's 2 equals A1 times R to the 1 minus 1, which is 0. Plug in 3 and 12. A3 is 12 equals A1 times R to the 3 minus 1, which is 2. And then what we do is we take this first equation and we divide the second equation by that. So I put 12 over the 2, and I put A1R squared over A1R to the 0. And the whole reason we do that is things work nicely here in that the A1s cancel. So I get 12 divided by 2 is 6 equals R to the, and we subtract the powers. So I get R squared. So therefore, R is the square root of 6. That's a little tougher of a common ratio. It's not too bad to write. So here, to multiply 2 by that common ratio, I just get 2 square root of 6. To get the fourth term, I take 12 times the square root of 6. Now to multiply this by the square root of 6, I mean, if you want to scratch some work out here, take that times the square root of 6. Remember, any square root by itself gives you just that number. So this is going to be just 6. 12 times 6 is 72. The other thing, and I'm going to end this video here, is if going from the first to the third term is a product of 6, then going between the second and fourth term would also multiply, or by the third to the fifth term would be multiplied by 6. All right, we'll continue in the next video.